Hi everyone, welcome to Embodied Dynamic Math Play EDCP 551 Teaching and Learning Embodied Mathematics Outdoors and via the Arts. Presentation overview starting with introduction till extension activities. Introduction, it starts with an overview. In this lesson plan, we explored an innovative approach to teaching Cartesian coordinates and graphing by taking the students outdoors. Inspired by the holistic principles of the ancient Gurukul system, this dynamic exploration integrates embodiment, gestures, and multisensory experiences to deepen students' understanding of mathematical concepts. By promoting inclusivity, we celebrate the diverse cultural heritage that each student brings, fostering a sense of connection and value. This approach not only enhances mathematical proficiency but also cultivates real world navigation skills and interdisciplinary connections. India has had a rich tradition of learning and education since ancient times when the Gurukul system was the center of learning. Gurukul system was a kind of residential schooling system, the residence being the house of the guru, the teacher, where all the students coming from diverse backgrounds, different cultures, and whether poor or rich, stayed with each other and used to do all daily course, motive to impart practical skills. Many physical activities using their bodies and the learning of different disciplines in the natural surroundings, mostly being outdoors. Chandwani in his article said that Gurukuls emphasized learning in natural surroundings, fostering brotherhood, love, and discipline among students. Subjects like mathematics were taught through group discussions and self learning, along with arts, sports, and crafts to develop critical thinking. These outdoor activities contribute to students' personality development, confidence, and mindfulness, essential for navigating life's challenges. Also, according to Snake and others, participating in physical activity offers numerous benefits for children and adolescents, including improved physical and mental health, enhanced self esteem, and better academic outcomes. Embodied cognition underscores the interconnectedness between physical experiences and mental processes, highlighting how our understanding of the world is shaped by our bodily interactions. By engaging in hands-on activities, sensory exploration, and movement, students can tap into the power of embodied cognition. I choose this idea because it aligns with the numerous benefits associated with using physical activities outdoors. The tradition of the ancient Gurukul system, which focuses on holistic education, is an excellent inspiration for integrating embodied learning techniques. Furthermore, incorporating physical activities with hand gestures can significantly enhance the teaching of abstract mathematical concepts, making them more tangible and engaging for students. Now, connection to professional and academic literature. Abrahamson and others in the article wrote about embodied design. By leveraging students' sensory motor capacities, we integrate physical experiences into mathematical learning, facilitating mental processes that enhance sense making, inference, and proof. Gesture studies reveal that mathematics teaching and learning is embodied. They say through playful learning principles, we engage students in technology based, joyful, and challenging tasks. They wrote, whole body collaboration reshapes learning environments and facilitates collective mathematical sense making, emphasizing the importance of incorporating embodied practices into mathematics education. Valentini and others also told about gestures that they enhances mathematical learning outcomes backed by multiple studies. Interdisciplinary protocols, particularly those integrating movement, have a positive effect on mathematical learning. In couple of articles in Kelly and others and Snake and others have written about integrating motor activity into mathematical education can enhance learning outcomes, but barriers like limited time and resources hinder its implementation. Martha and others. Gestures in mathematical cognition indicate the embodied nature of thinking and speaking, revealing connections between abstract concepts and physical actions. Also, Emilia and Jonas in their article emphasized about the benefits of outdoor learning. Singh wrote, integrating integral humanism, the ancient Indian education system, embodied cognition, and the development of curiosity can foster holistic education and empower individuals to thrive intellectually, emotionally, and socially. Even Chandwani, written in his article, outdoor learning activities as practiced in Gurukuls fostered a holistic development approach by nurturing students' personalities, confidence, discipline, intellect, and mindfulness. Engaging in various physical movements outdoors facilitated not only academic learning but also the development of essential life skills required to tackle real world challenges effectively. Personal connections. My personal upbringing, immersed in outdoor activities, blending playful learning and nature exploration, underscores the profound impact of experiential learning on personal growth. Integrating embodied mathematics inspired by the Gurukul system feels like a natural extension, honoring the transformative power of immersive education. School connections. Growing recognition of experiential and embodied learning in Vancouver and nearby districts, BC schools prioritize culturally responsive pedagogies and offer outdoor education programs. So it's my opportunity to explore Gurukul inspired pedagogical approaches within this educational landscape. Integrating embodied and movement-based learning, experiential and embodied learning pedagogical approach inspired by the principles of the Gurukul system. So my activity is embodied dynamic math play, grade 7 of BC curriculum, Cartesian coordinates and graphing. Class starts with a brief explanation of the Gurukul system, emphasizing its focus on holistic learning, community engagement, and the integration of various subjects beyond academics. Teacher also mentions how this approach aligns with the dynamic and embodied nature of the outdoor activity we are about to engage in today. The teacher will take students outdoors. The teacher will divide the class into two teams. Students will stand on two lines perpendicularly intersecting number lines intersecting at the point 0. Two students together making the symbol of 0 with their hands will stand at the point of intersection representing 0 using gestures through their hands. Then one team of students is divided into 4 equal parts and each one part of the students will stand on 4 sides of the 0. Students stand by stretching their hands in both directions, left and right body parts for them. These hand gestures will show that the entire area of both sides has the same positive or negative sign. With hand gestures, the students, means the X's and Y's, can quickly figure out the signs in each of the 4 divided areas. Where are you standing now? Okay, so can you move to on x-axis on the place number 2? Here is the game. The teacher will say a pair of number. Negative. Whatever number she will say every time the first number X's will start moving first and take the exact number of steps as the designated number towards left or right based on the sign and stand on the changed position, and then any number from Y's as indicative from the pair number said by the teacher move. So can you meet at the coordinate -2, -3? So what is your location now?
Negative 2, negative.
Which quadrant you are now?
3. We're both negative. That means we're in the third quadrant.
Both students stand in the same place, indicating their position as the ordered pair.
Negative.
Very nice. The teacher says a few more pair numbers with different signs.
Number 4. 1, 2, 3, 4, 5.
Very nice. So what is your location now?
5,4.
In the first quadrant, because both the numbers are positive.
So now you what till now what you have learned? You know what where is the origin?
The origin is 0, 0, which lies in the center of all quadrants.
What else you have noticed?
All the coordinates in the first quadrant are positive. Third quadrant are negative. All the coordinates in the second quadrant
Are negative,
comma positive, and vice versa. For the fourth quadrant, they're positive, comma negative. Can we also create some numbers in the second and the fourth quadrant?
Okay.
Later on, students get excited and choose numbers themselves and move accordingly. Then the other team will play after watching the first team.
Positive value. That's why I want to be positive 2 in the y-axis. 1, 2.
since we have to be in the second coordinate.
Start by showing the technique to two students first and then playing it with a large group.
Now we meet at the point -3, comma positive 2. So I'm going to go 1, 2, 3 steps, while Rebanta is going to move 2 steps.
1, 2,
Now we're the point -3,
3, comma negative.
positive 2. Need to face that way. Now we're at the point -3, comma positive 2 in the second quadrant, where all the x coordinates are negative and the y coordinates are positive.
Very nice.
Students will understand the four quadrants and the signs of x, y, that ordered pair in each quadrant, and graph any point in any quadrant.
So have you enjoyed?
We have
After the outdoor activity, the teacher transitions the class to the classroom to discuss real-world applications of Cartesian coordinates and their use in locating landmarks globally by
Latitude
their
and
latitudes and
longitude.
longitudes, a way to
So what I
interdisciplinary
have
connections.
here is a Cartesian plane that you're probably familiar with from math class. So does it look familiar to you? The difference here is that instead of negative numbers and positive numbers, you're going to have north, south, east, and west. West, 60 degrees west, goes all the way to 180 degrees west. Latitude, longitude, until our fingers meet. Again, it was 60 degrees north, 120 degrees west. That's in North America.
Okay, now let's use longitudes and latitudes to locate places on a map. The latitude and longitude position of any place on Earth is called its coordinates, with the latitude shown first and the longitude shown second. So if I asked you to look for a mystery place with coordinates of 30 and 31, you would find the latitude at 30 degrees and the longitude at 31 degrees, and where these two lines meet is our mystery place, the Great Pyramid of Giza. And in the same way, if I asked you to look for another mystery place with coordinates of -3 and -59, you would look for the latitude line at -3 degrees and the longitude line at -59 degrees. And where these two lines meet, you would find our second mystery place, the Amazon rainforest. So, as you can see, each place on Earth has its own unique set of coordinates made.
So, what exists at the location where the equator and the prime meridian cross each other?
On the second day, students practice locating themselves on the Cartesian plane and calculating horizontal and vertical distances from the axis.
1, -3 in the fourth quadrant.
What is your distance from the y-axis?
Our distance from the y-axis is currently 1 unit, since we are 1 step away from the y-axis, and 1 is the x-coordinate in this case.
Very nice. Rebanta, what is your distance from the x-axis?
Our distance from the x-axis is 3 units because our position is -3. But it's not negative because distance cannot be negative. Only displacement can. And also we also 3 steps further from the x-axis.
What is the coordinate that you want me to go to?
3, 4.
Positive 3, positive 4?
Yeah.
They further engage in forming triangles using ribbon or rope to connect different points, allowing for hands-on exploration of geometric concepts.
Devanta, can you move to -2, 4?
Ooh, we made a triangle!
And we have 3 vertices for this triangle, including my coordinate, which is positive 3, comma positive 4.
My coordinate, which is -2, comma positive 4.
And I am standing on the origin, that is 0, 0. So, can you tell me your distance from the y-axis?
My distance from the y-axis is positive 3 because I took 3 steps in the first quadrant.
Remember, what is your distance from the y-axis?
Positive 2 because I took 2 steps from the y-axis.
So, what is the distance between both the points?
Since I took 3 steps from the y-axis and
I took
Rebanta
two
took 2
steps.
steps, that means it is 3 plus 2.
5.
So we are 5 steps apart from each other.
Moreover, they explore one transformation, setting the stage for further learning.
In nature, it feels much more nice and interactive. This is way more fun, and this was a very interactive and memorable experience for me. I would prefer to learn all my math concepts this way.
I agree with her.
Because of your class, we have bonded even more, and I feel like we're even better friends now because we're able to coordinate better and understand each other better. Such nice values. We're gonna properly recycle it.
So, conclusion. Recognition of Gurukul's holistic approach fosters a natural learning environment, promoting students' development beyond academics. Dynamic exploration through embodied learning establishes deeper connections between math and real-world experiences. Integration of diverse pedagogies enhances student engagement and understanding, reflecting a positive student response. So, extensions. Students can explore outdoor environments beyond the school grounds, applying Cartesian coordinates to create their own graphs and calculate distances between points. Transformational learning. Teachers integrate lessons on transformations like reflection, rotation, translation using embodied dynamic math play in the same way, allowing students to visualize and internalize mathematical concepts through movement and gestures. Incorporate Cartesian coordinates and symmetry into weaving projects, fostering creativity while reinforcing mathematical concepts. Utilizing online mapping tools to create interactive maps of the school campus or local community, which enable students to plot points of interest and explore spatial relationships. Community mapping initiative. Collaborate with local organizations to engage students in mapping projects addressing community needs. Thank you.